Alrighty, let's see what we got here. Maximum score from removing substrings. You're given a string s and two integers x and y. You can perform two types of operations any number of times. I feel like I've heard this setup before, or something similar. Anyways, two integers x and y. Okay, remove substring a, b, and gain x points. Okay. I guess it has to be exactly AB. For example, we're removing AB from CABXBAE. It becomes CXBAE. And you get X points. Remove substring BA and gain Y points. For example, removing BA from CXBX. BAE becomes CABXE. CAB, yeah, and you gain Y points. Return the maximum points you can gain after the above operations on S. Can do those operations any number of times. Okay. Interesting, I guess. So this is a lot of A and B's. You get more points for removing BA. So they removed this BA and got 5. And then the next thing they did was remove the AB at the end and get 4. At some point they removed that BA and probably get 5. And then the BA surrounding that and get another 5. And I guess at that point there's no BA next to each other. Okay. So does order of operations matter here? I guess if there's a preference, then you'd want to use the. Well, let's just see. If you had like a ABA situation or BAB situation where you could choose to use one or the other, you would prefer to use whichever one gave you more points, I guess. But you're always using a single A and a single B each time, so it's not like it's gonna get some sort of imbalance. Like you're always removing the same amount of A and B's. Huh. I wonder, like, was there a non-optimal way of doing this, or could you do something greedy here? So you see that the BA is better for removal, so you remove this BA. Maybe you remove this BA as well. That leaves you with another BA there and a remaining AB here. So can I construct an example of something where a greedy approach fails to optimize, get the optimal number of points? So yeah, so the first question is can greedy approach work? Where the greedy approach is, greedy here would be always prefer to remove AB or BA, whichever one gives more points. So related to that would be can So one way to answer the question is give any example input where greedy approach fails. And if you can't, then it doesn't quite prove it. It doesn't quite prove that the greedy approach is optimal, but it's a pretty good hint, I guess. So A, B, 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 A, if you were to remove off the top of my head, I just can't think of one. So I think I'm going to try to go with the greedy approach and see if that fails. So how would I do a greedy approach here? Look at, so this looks like it would probably be a stack where you put stuff on the stack and you pop stuff off. And then you can pop off A, B, or BA as you see it. Okay, so let's go ahead and try a stack here. So for every letter in the string, actually I guess I need to see which one's preferred, right? How would I check that? X, Y. Guess I can do it both ways. Okay, well, this enough dilly-dallying. I guess I could always do something where I write code for, let's say that X is AB, so I could maybe write code that is strictly, let me go ahead and do something like this. If Y is bigger than X, so that means BA is preferred, I'm gonna go ahead and make the string equal to, I'm going to make an array of characters K be K for K in S, K I kind of want to do something where it's the same character if it's that character in the string. If it's A, then it becomes B. If it's B, it becomes A. Okay. How to make that for every character in S, characters can become was this string only lowercase letters? If okay, well maybe have a swap dictionary. A becomes B, B becomes A, and then K, if K not, oh, I don't know if this is correct syntax. If K not in swap, else swap of K, K and S. I don't know if that's correct syntax. I feel like that's incorrect syntax. Let's go and print the array. Yeah. Here's another way of, I'm supposed to write the if-else part here. Python list comprehension if-else. Blank if this else this for x and that. K if, oh whoops, I forgot a second K. K if K not in swap, else swap. Okay, I think that actually might be right then. Oh, yeah. This is strictly local to the branch. Okay. So y is bigger than x, so it's going to do the swap a becomes b basically, and b becomes a. So at that point, I can treat it as a is more, ab is more, ab is strictly better than ba. So xy is yx. So this. Okay, so I guess actually I need to make the string to become this array. I wonder if I could just use the s is equal to join the array. Guess that's fine. Okay. Okay, for every, so the stack is that, so it's going to prefer AB. It's going to prefer AB. So for every letter in S, if the letter, so if this letter is not A or B, then that's strictly going to go on the stack. If letter not equal to A and letter not equal to B, can stack.append. Actually, do I even care? It's not like I'm returning the, it's not like I'm returning the string, right? I just return the output. Interesting. Huh. That is true. I'm not really returning anything. I guess I could say the stack is reset at that point, maybe. Yeah, maybe I can say the stack resets. Like anything that's on the stack then cannot be working anymore. I think I actually probably want to use indexing here. Enumerate S. So letters stack is going to reset here. And then continue. Yeah. I don't even know if I should be using a for loop here. Okay, that's probably fine. For loop's probably fine. Okay, so here the letter is going to be A or B if it continues past that if statement, or if it is kind of in the else portion after the if statement. So if it's an A or B, I am almost assuredly going to put it on the stack. And then what? So if it's on the stack, I guess if the stack is then if the stack has an A, B at the end, then I should prefer to remove it. The stack has if the stack has A, B at the end. If the stack has a B, A at the end, what happens? The stack has a B, A at the end. Can the stack have multiple A, B's at the end? So I can do something like this while stack at -2. Well, while the length of the stack is greater than 1 and stack -2 is an A and stack at -1 is a B. I should probably say stack at second to last character and stack at last character. Then stack.pop twice and answer is adding the X value. So we can't actually do this twice. Like it can do it once, but it can't really do it twice. Like there's no way that if the stack has A, B, if you remove the A, B, then there's another somehow A, B after that. So it would have been popped before that. I guess this should be an if statement then. Stack has more than 2 characters. So if it's a BA, when does the BA get processed? The BA should get processed after you know that there's no AB. The BA gets processed after you know that there's no AB. B A B A B A B. Okay, so B A B. What happens here? So you want to do A here. You want to do an AB here. You want to do you want to do two ABs here. And you want to do an AB and a BA here. So the AB gets processed. Interesting. AB gets processed and we should get a BA afterwards. So you hold on to the B's. If you see an A and followed by B, you process that immediately. If you see a B, you hold on to it. Guess you would just hold on to it indefinitely, no? But you need to hold on to as many as you can. So then it could be like a bunch here. But if you see something that is like AAA, I guess you hold on to the A's as well. So you push onto it, remove it, push onto it, remove it. You hold on to the B. Hold on to the B. So if you hold on to the B, then you push on all these A's here. Would you? Yeah, I guess you would. Push on all these A's. Because if there were more B's on this side, then you don't want to process BA's before the AB's. So at some point, so when would you process the BA's? I guess you process the BA's when the last A is followed by something that's not a A or B. At that point, you would start processing the BA's in the stack. Yeah. So you keep all your A's, you keep all your B's in your stack, and you might have a bunch of B's in your stack. Anytime you see an A on your stack, then you would hold on to that as well. And then any follow-up B, then that'd be an AB. So you'd have on your stack a bunch of B's, a bunch of A's, possibly. And then you know to stop that when you see a non-A or B, you need to process it. It's the other way around. If it's a bunch of A's followed by a bunch of B's, then A's B would be processed immediately. Okay. So I guess here, before I reset this, I would need to, should I have a count of the number of B's so I know where on the stack to go to? Stack doesn't actually make sense, kind of. Yes. Count B. Count A. I guess here. Stacked up, append the letter. I guess I could say here, if letter equals A, count A, increment. I guess I don't need to have both counts. I could probably do one or the other and do subtraction from the length to find the count of the other. So letter, so I guess here I should decrement the count A's. Okay, so you pop A and AB immediately. Yeah, and here there has to be some number of B's and A's in a stack. So I can say the count B's is equal to length of the stack minus count A. And then if I were to do a quick quick combination of them, it would be answer plus equals the min of the count A and the count B times Y, and then reset the values. This is probably probably be better to reset the stack after I do that. Okay, I'm gonna count B's in the stack. BA. Reset the stack, continue. Otherwise, put the letter onto the stack. And then if I see anything that's AB, then just remove the top of the stack. Well, that looks actually kind of fine. I don't know if I need to do anything else. Guess I need to do something else. 19 versus 15. Alright, let's go ahead and just quickly check to see this string. This should have swapped the B's and A's. Okay, it did. If letter, which I could probably keep track of just the counts, if I think, now that I think about it, rather than keep track of a stack. I'll probably change that in a little bit, just to figure out what's going on here. So the A became B, became A, and the A became B. It's fine. So it should have processed this AB first and get 5. And then it should have processed this AB and got 10. And then it should have done the B, this AB, and got another 5, so it's 15. And there should have been a BA at the end. I see. It's at the end. I don't have anything processing the stuff at the very end. Like if I were to print out the stack here, it's going to be a BA at the end. And I didn't calculate the value of that after the loop. So it should just be same thing here. Count B is equal to length of stack minus count A. Answer plus equals min of the count A and count B times Y. Okay. Yeah, this doesn't need a stack, I'm pretty sure. I could probably just get away with using variables for the streak of B's and streak of A's. Okay, let's go and do a little bit of optimization here. So I just need to know the streak of B's, I guess, and the streak of A's currently on the stack. Yeah, okay. So I can say here, I think this is fine. I wonder if I should just be using an integer array. I could do something like array is equal to the ordinal of k, where k in S, and then secondarily array is equal to, actually let me think about this, ordinal of k if k, okay, actually, let's do the swap with ordinal values. It's ordinal A, um, A, I want to become 1, and at B, I want to become 0. Array is equal to ordinal of K minus, say I have an offset, this ordinal of A, or minus the offset if K not in swap, else use the swap of K. Okay, and then print the array, I guess. Just make sure. Okay, yeah, so I did a couple of things, just kind of don't feel great about doing it, but it's basically converting the string to an integer array. Normally I would convert it straight to the ordinal values, kind of where A is 0, B is 1, C is 2, and so on. The way that you'd normally do that would be ordinal of the variable of the character minus ordinal of A. Ordinal value offset to become 0, 1, 0 through 25 for 0 for A to Z. But in addition to that, I also am doing the swap. Actually, this swap needs to be inside the if statement. Okay, so I think I need an if statement here. So I say if x is bigger than y, do the kind of normal setup, which is ordinal k. I guess offset needs to be before this if statement. If k, for k in S, else array is equal to ordinal k minus offset if k not in swap, else swap of k for k in S. The swap does this. Okay, I think that's great. So if there's a preference for AB, or there's a preference for BA because BA has more points, I go ahead and convert B's to A's and A's to B's, or B's to zeros and A's to ones, so that I always have a preference for AB later on the code. This is if more points for BA, convert B to A and A to B, so that reference is always AB. So that AB, always better. If more points, and I also need to do the xy is equal to yx. Okay, so I think that is, so now I have an array of integers. I can just work with that rather than with the string. So for every index, and I guess you can still consider this a letter, but it's more like an integer value of the letter. In enumerate of the array. So I think I need answer 0. I need to count b's. Yeah, I need to count A and count B actually, because I don't have a stack anymore for this next part. Actually, I probably should keep this old code. I'm just going to modify it. So I can say here if the letter is not equal to, actually if the letter is bigger than 1, in which case it's not a letter, that's A or B. This is going to be, so because zeros A's here, above here, this can be convert string to array of ints where A through Z is 0 to 25. So this is i.e. letter isn't A or B. A is not A nor B. Then I'm going to say count of, actually I'm already keeping track of the count of A and count B, so answer plus equals min of count A, count B times y, count A is equal to count B is equal to 0. Continue. Okay, otherwise I'm going to say I wonder if there's a fancy way of doing this next part. So if the letter is equal to 0, that means it's an A. And if the letter is equal to 1, that means it's a B. So I think I can do something like this. Count A's plus equals 1 minus the letter. So the letter is 0, that means it's an A. 1 minus 0 is going to be 1, and it's going to increment by 1. And count B is also going to increment by the letter itself. So if the letter is 1, then it goes up by 1. If the letter is 0, then it goes up by 0. Okay. And here I can say if the so I think it should be if the count of A is greater than 0 and the last letter was a B. If the count of A is greater than 0 and the last letter is a B, then it has to be that I should be able to remove AB from last set. Count of A decrements, count B decrements, and then the answer increases by x. Yeah. And then one last thing would be count after the loop would be answer plus equals min of count A, min of count B times y. I think this is the correct translation of the other code. Oh. Okay. It's faster, but not fast enough. Do I care about this? I guess I could possibly do it. Could possibly do it in place. Guess this is pretty complicated. Maybe. Not sure. This thing seems pretty. What is going on here? Yeah, I think this is necessary. It does seem a little redundant. I'm counting A's and B's. Maybe there's a way not to do both. Ordinal. Swap it. Ordinal, okay. We swap, it becomes 0, 0 becomes 1. Oh, this code gives me a headache. And I wrote it, which makes it even worse. How would you make this more? How would you make this better? Do you? I think you still want to use a streak. You still need to know how many B's and A's are waiting to be kind of processed at the very top of your stack. I don't want to have a bunch of if statements saying process A, B here if x is greater than y versus don't process it if not. And the logic. I feel like this if statement really, I like separating the reversing A and B's in order to make the reversing A and B in order to make it not have to have that logic when you're doing the counts is pretty helpful. I wonder if I could I wonder if I can just look at a streak of B's and A's and predetermine how they would kind of compute out. If you have some number of B's and A's grouped with each other, is it always possible to know what is the cancellation? Maybe. So you have plus B plus B. So you could push a B onto the stack, push a B onto the stack, push an A, push an A, push an A. Whenever you push a B onto the stack, you pop the A from the stack. If the A is on top. And then so you push B's, you push A's, you push B onto the stack, push A on the stack. Then you push a B and pop an A off the stack. This is what I did before, now just without. I wonder. If the letter is an A, letter is a B, I guess. If the letter is an A, you always push into the stack. If the letter is B, then you remove it. Then you remove it from the stack. Now A is greater than 0, and the letter is B. And you take maybe I can do a statement here. I guess I could probably do this before the other stuff. So if there's an A and the letter is B, then rather than just do this and continue, guess that probably works, right? Yeah. So you're not just adding onto the stack, you just delete. Oh shucks. Why wouldn't that? If there's A's and the letters B, then just remove both the. Oops, I forgot to remove an A. I can make this an else if. No change. Absolutely no change. Oh. All right, I think I'm going to call this one. This code is way too unclear, I guess. If there's more than, if the letter's not A or B. Yeah, this is not my greatest work by far. So it's just gonna go summary here. Summary, this is gonna be a greedy approach. So greedy approach. This is try to delete AB or BA immediately. Whichever gives more points, to make it consistent. To make it consistent, can swap A, B's if y is greater than x, and thus always prefer to prefer AB over BA. And then secondarily, it's going to be, or next would be and above optionally converted the string to integer array of kind of ordinal values. I guess it's not ordinal values. It's convert the string to integer array of kind of integer array where A to Z converts to 0 to 25. Thus logic is we'll use comparisons to 0/1/x for A, B, and other characters, other letters. So main idea would be, is counting streaks. Where any number of B's, basically ones, can be streaked. Followed by a streak of A's, no zeros. If a B is added onto is the next letter, then immediately process AB, because you have a streak of B's followed by a streak of A's, and then there's a B, so that'd be an AB there, which is decrement count of A streak, and add x points. If a non A is next letter, then process the streak of B's and A's to form some number of BAs. So, for example, you have 5 B's followed by 4 A's, or 4 A's followed by D. This 5 B's, 4 A's would make 4x, 4y, 4 BAs, which would be 4y points. Alright, yeah. And then repeat until end of string array, and then do final addition of remaining streaks after loop, since it's terminated by the end of the string. Yeah, this is not my best code and definitely not my best explanation of what the hell happened. Time complexity, this can be O of n, where n is the length of the string. Yeah, which was necessary for the computation of streaks and for the exchange conversion to integer array form. And then space complexity, this is going to be also O of n for integer array to make the logic easier. Yeah, so there's the logic for converting it from character to integer array, where the integer array is 0 to 25 for A through Z, and also the logic for doing the swap so that B's is treated as A's and A's treated B's if the points indicate that BA was more than AB originally. And then there's some code to process it using streaks. Again, this is probably a little easier to comprehend with stacks, but as the case may be.